data type work that we do. Okay, I've been at Children's Mercy for almost 10 years now, but I've been in industry for close to 14 years, previously at Cerner.
All right, thanks both of you. So I think maybe to get things started, Harpreet, could we start with you and could you talk a little bit about capabilities that the team at Children's Mercy has recently developed with respect to being able to gather data from wearable devices, and then we can maybe talk about where that can lead to.
Got it. Well, thank you, Dr. Thompson. I think when we talk about wearable devices, there are different categories. So I'll probably talk in general about it, but when I'm talking in general, there I'll just give you a little bit of hint. Sometimes they're all clinical based, sometimes they're just activity based. Like for example, when we talk about activity based, it's mainly your smartwatches, smartphones. Now we have smart rings also. So all of those type of devices get categorized into that. Then there's also clinical slash more health outcomes related devices, which are your CGMs, continuous glucose monitors, air quality monitors. Um, let's see what other components you go around your holistic health and add whatever you want to add to it. So we collect data from multitude of things. About 5 years ago, we realized that popularity of these devices are, I mean, like it's getting very common. Everybody has a smartwatch. Everybody has like air purifier at home, and they're interested in seeing how it impacts health. And no-brainer researchers were also interested in, well, is it actually impacting somebody's health to wear a smartwatch? So that's where it all started. And it was also great to see that companies like Garmin, Apple, Fitbit were also coming up with ideas saying, hey, why don't you use our data sets and tell us how it's doing in the real world? So we jumped on that opportunity, and to keep it short, we built a platform. We are calling it Health Device Portal. What that platform does is gives you a very basic sort of uh, a website in a nutshell of other things where you can go in, configure your devices. It supports, I think, 5 to 6 vendors at this point at Children's Mercy. I also believe it was using to do a lot of Carmen data collection. So at the end of the day, data comes in. It gives you a very, timeline-based data, so you can choose to do research on it. It doesn't do research for you. It won't do any complex research for you. It's a data collection tool, but we thought that's the most powerful tool to give you that data set as research for somebody interested in research and drive your insights from that. So that's a very high level what Children's Mercy does. The scope is very deep, so I won't go into that, but that's where we are at right now.
And Lav, can you talk a little bit about how this capability has been deployed at KU?
Yep. So both of the software which has created by CMH we have deployed here. Um, that includes Health Device Portal and Diabetes DDataDoc. So Health Device Portal uses Garmin Wearable, where DDataDoc uses CGM data. And both we have deployed on Azure. I think the main part I think we have learned is the developing is one part and actually making HIPAA compliant and NIST compliant. So we do HIPAA and NIST compliant here at KUMC. That takes lots of effort from the infrastructure perspective.
Yeah, that that is true. But overcoming that challenge is an important part of being able to move forward with developing what we want to do next. So I think that was a great thing to bring up. Okay, so we've set the stage. So we have developed this capability to be able to collect data, maybe not on all wearable devices, but from a pretty nice range of wearable devices at this point. Or we're also potentially talking about um, I guess maybe I'll say in the grand scheme of things, personal health devices of various sorts, including CGM, and not yet implantable devices, but maybe sometime down the road. So that said, going from there, can I get both of you to answer your thoughts on how we can connect that to innovating in the AI space and why it's important to add this source of information in addition to the type of healthcare data that we normally collect from people? So,
Thanks, Love. Take this.
I was about to say the same, Lam. Could we maybe get you to start?
Yeah, I think that it's a big untapped data. So the way I think about the what CMH has created is really good infrastructure we can use across multiple PIs. So in the past, what used to happen is PI comes up with idea, they have their own pipeline, and the project is done, and then pipeline get destroyed. Here, the pipeline is for the entire institution, and it can be used over a period of time. And there are dedicated resources who are expert at those data. So that's something which is very innovative part of this collaboration. In terms of specifically how can we use this in AI data, how can we use this for AI? I always like to think from end user perspective. If this is for clinical, we have to start thinking from, okay, what does that 15 minutes look like for clinician and what they actually care about in that 15 minutes. And then we can go from backwards from there. We can come up with very innovative AI models and clinician might not care about it. Um, and if it's a research, and there are so many great scientists we have at KU and CMH, they have excellent ideas. And these are untapped resources which are just waiting to be used. Um, and we are open to like go on both direction.
Great. And I love the fact that you brought up, well, what is a central mantra to me of design, which is that we start from the user and work our way back from there, which is great. And also, I think that the idea of centralization here is really important because historically speaking, what's happened is that everybody starts doing their own development on each individual tool, collects their data, keeps it there, and it's all done in 1,000 different ways. And that at least is not happening now that we have this infrastructure, and that really helps to accelerate progress. So Harpreet, how about you, your perspective on this?
I think I'll add on to what Love mentioned, and I think that was a great point because our initial motivation was, yes, we were getting tired of doing it again and again for base, but you still have to get it up and running, get those ready in cloud or wherever you are, get the data from there, give it to the researchers. And that's where it was getting too cumbersome. So just to give you a simple number, right now it costs us 10 times less than what it used to cost us to run one study when we didn't have this platform. Right now, we do a full garment study, probably around 90 to $100 a month. That's all it costs to run it. It's costing a lot more money initially because you have to keep spinning up things, bringing them down. Even today, even if you customize some request for researcher, is fairly straightforward, not as expensive. That was one angle. Is just at the end of the day, if we have researchers have money, they can invest in things that they really need instead of just worrying about infrastructure cost. And that was one of the initial encouragement to do this. Going back to the concept, so when we talk about AI, like from the there is AI has a huge window. You can call a lot of things AI. The way we look at it, like one thing you can do is like take all the data, give it to an existing agent, and let people ask whatever they want to ask. That's like an extreme way out there use case. A more tailored use case, which we have already seen in many, we've already published this, is building a basic model that can predict XYZ based on what it has seen in last 6 months. So, there are different flavors. As Love mentioned, some researchers, we have one project which goes in the different direction, which says, you know what, I have all this data. I want my participant to ask whatever they want. So that's a very different use of data set. Whereas where we are tailoring it to something more close to a machine learning algorithm where it's predicting something using a well-established, academically proven mechanism. So again, just to understand the realm is very big. AI is used right now in our industry is just, you know, lack of a better word, bananas on it. So there's different ways of looking at what AI is. But in our context, when we look at it, the main component for us is the cleanliness and the actual reliability on data. So that's one thing we spend a lot of time on. When we collect our data, we make sure it's appropriate for that particular use case. Data duplication, faulty data, bad data, all those components are already built into pipelines, so that we don't have to do that effort on our data science side of things when we are building these mechanisms. So that's very important in our perspective when we look at it like how we will use it in coming months and years, because absolutely is going to be used for building these systems. Again, I'll probably keep it short. The idea is that possibilities are limitless, but at the end of the day, you need to have that right data set. You need to have that right building blocks to build something that's actually useful. Going connecting dots to what Love mentioned earlier. You want to build something different, and that's how we tailor our approach.
Great, thank you. So building on that question then, so you both talked about one of the real changes here in terms of being able to operationalize working in the AI space with this type of data is the fact that we have built this consistent mechanism to collect the data and manage and store the data and make sure that it's clean, all those pieces. And that way, that work is not being repeatedly done, and we know that it's being done in a correct fashion, so to speak. So the next step in my mind to that is, well, how does that connect to AI development? And how do we solve the same set of problems, which is like, how do we make sure that people have a consistent way to do that and overcome barriers historically that have existed in our institutions to doing that development? And I'll mention some if you don't, that, we can solve by the centralized platforms that we have in which to work. So whichever of you wants to start off there, if you have some thoughts, or I can provide you some more.
But I can take this one, Love, because I think I've pushed him. And again, it's I think Love's perspective will be different on it because his approach is in a different area. The way I look at it, I, I think principles don't change. That's the good thing about engineering in general. The principles are still the same. When you provide a service, now AI, again, going back to this idea of it's pretty wide. What makes more sense for an institution like Children's Mercy or KU is a conversation that we as peers have to have overall. To give you one context, one of the projects we are actively working on right now has to do something with if a participant is being consented for a study, how do they get more knowledge instead of just having a ton of packet from research? AI play a role in that area? Absolutely, yes. But what that pipeline looks like is going to be complex as we grow. Well, my 2 cents in this is at the end of the day, if you have engineering components aligned and available as a platform slash service, it is much easier to have a conversation with a researcher when they come to us and say, hey, by the way, this bright idea in my space is going to solve a lot of problems. We can then say, you are the subject matter expert. These components already exist. So at the end of the day, let's say you're using whatever model you want to use. I'm going to just, Azure offers hundreds of different models, which you can leverage. Those models won't know much about what you are doing specifically, but they can be trained. So if that can be replicated on different projects, so some of those problem sets in that area could be solved by just providing that service expertise so that the end user doesn't have to come up with that expertise. That's our goal going forward, Mercy's perspective in this space.
Well, what do you think?
Yeah, I think one thing I would add, I think I agree with Harpreet said, and we have also AI committee, and we try
Mm.
to make sure that every AI product we develop, there is a human in a loop. That is the central piece of any kind of development. So we have a AI scribe tool. Even though it does excellent job, uh, it has to be reviewed by a clinician and say, oh, I reviewed the note, and then it can copy and paste to EHR. So that's another central part of making sure that AI only uh, is not just doing by itself. Um, so the second thing I would bring out uh, is making sure that it has equity across the different demographics. So if you have, like, for example, and this is we still need to address is, let's say if the device requires cost is like $400, um, then your population is usually affluent population. So we may have to target research and focus on rural area or the people doesn't have significant economic background. So those are the couple of things which comes to my mind if what kind of area we should focus on AI, which creates like long-term impact, not just to affluent uh, population, but just across the entire population.
Yeah, I mean, to that point, which I think is an excellent point, and is one of the barriers to successful deployment of these types of tools. At KU, one of the things that we're working on is making sure that we also have a centralized set of tools for assessing the performance of models, and that we can provide those to people in a consistent fashion. And again, the whole idea here is, how can we stop starting from the beginning every single time somebody does one of these things?
Mhm.
And they have to discover how to do um, the I'm trying to avoid technical language, but how to avoid having to do the drift monitoring or bias detection or those sorts of things that are key to successful deployment of a tool and maintenance of that tool over time. And so part of what I'm driving at here is that there was a big push, probably for the last 15 years, I would say, to do what we would call democratization of data, as in to make it easier for the end user to be able to access and work with their data in a relatively user-friendly way. A lot of tools have come out to try to make that possible. Databricks and Azure platforms provide a number of them, and that's part of the reason we use those platforms, is it makes it easy for us to govern people's access to the data so that we can feel comfortable with making it easy for them to use. So some of the things that you're talking about, in my mind, touch on the topic of democratization of AI, which is a tricky topic because there's a lot of cybersecurity issues and such this around it. But nevertheless, how do we make it easier for people to connect AI to that democratized data that we've already created? And things like, the health device platform and so forth, democratize data. So now we have to take the next step and connect it to AI. And so, as Harpreet mentioned, when we use a tool like the Azure platform that already has a lot of built-in AI technology, they're one step closer. Because normally speaking, what happens is that people have to go to whatever their institution's Office of Information Security is and say, I want to use this tool. It has to be reviewed individually. And then the next person who does the project, they start from scratch and do the same thing all over again. These platforms may make it somewhat easier for us to say, we can just turn that tool on for your data and you can start from there. So thanks for that perspective on that question. I'm going to encourage I have a few more questions, but I'm going to encourage the audience that if they have any questions about either their own ideas that they have about how they would like, what they need to know in order to start putting AI on top of wearable device data or anything along those lines, that I would encourage them to ask those questions. So that said, we do at least have one example of a project in which we are using AI on top of a wearable device data, so to speak, with the CGM. So I'd like you both to talk a little bit about that, if you could.
Sure. I think that's you're referring to Datadog.
Yeah.
Um, um, so I think to give, there is also publication out there, and I should have had the link ready, but I could post that link in this chat. That way you can read more about it. Again, taking the 30,000 feet picture for what it does. About 5 to 7 years ago, where this idea started building up was you're seeing a lot of type 1 diabetes admissions and pediatric cases, and trying to understand what's going on. Is it actually working? Our interventions are really working? What's happening over that whole idea, which is a very noble idea in general. So there's a whole Rising Tide Alliance. There's a big research initiative push behind this. So a lot of effort they have done. So don't want to take up their groundwork they did to set it up. But basically, when it came to us, our idea was core is to collect data over a certain period of time, try to see the trends based on XYZ factors. And there are other factors involved, not just CGM data, just to let you know, to make this model work. And then predict, is there going to be an onset of, if you see, will you see somebody in emergency room in next coming days? So that was the goal. Can we predict that? To some extent, yes. So what it does, again, not going into, and I'm also not the data scientist who actually worked behind it. So I do want to make that clear. I was on the data engineering team, but our core goal was there's a different medallion infrastructure when the data comes in. Again, going back to the idea, data should be clean enough to actually run these models on. So a lot of groundwork is done to make sure that first happens. Once data is available in that clean format, is often called like there are different terminologies for it. In Databricks is like gold standard or whatever you want to call it, but the data is looking good. That's what I mean. Based on that, what the system can do factors involved in the data collection from CGM. It can predict an onset of a certain condition. It can flag our clinic saying that looks like this person might end up needing some sort of critical support going forward. In some cases, that's what it is. In other cases, it's more about their habits are not aligning well. So there's a six habits prediction model. Their habits are not aligning well with what should be, and based on that, please go and contact them. So it can predict with some proximity. It has done like we when we did our testing, it was very close to what we would have expected from our cohort. So our clinic uses it every morning to say, looks like this set of people might need some intervention at this point, and they record that in some sort of clinical event and then say, okay, we are reaching out to this person based on this model's prediction of their A1C. And I might be wrong. I think it's last 30 days, unless love you remember. But it takes into that last 30, 90 days of your trend, and based on that, it can make a prediction of looks like in next 7 to 10 days, you might need some support. Again, this is more paraphrasing, a lot of summarizing that model, what it can do, but at the core, it uses your CGM data to predict will you need any help from clinic in the short term.
Clive, do you have anything to add to that?
Yeah, I think Harpreet covered pretty much the whole product, but I would add the last part is when the patient comes in at the Dr. Tilden, who is the champion for DDataDoc at KUMC, what he likes to see is what patient needs additional attention. So that's what like when patient comes in, he look at the dashboard which is generated by these AI models, and he wants to see which patient he should spend more time compared to the patient who is following all the treatments correctly or taking all the medication correctly, or his glucose monitoring level is producing the correct graphs. So he can prioritize which patient should get more time. And I think that's kind of outcome you want to see that, oh, it's actually been affecting the patients. So that's I would just add to that. Yeah.
So a question I have for you on that front is that I think, the present company excluded, but I think it's worth talking about anyway. A lot of people would assume that the information that we're talking about, especially if you're talking about a CGM, is in the electronic health record. So can you talk a little bit about the importance of being able to have the capability of building these tools outside of the EHR and why we need to do that?
Sure. I think most of Epic currently doesn't have a capability of integrating CGM data. So that's why it needed to be built outside of EHR. I think that's the reason the CMH started building this organization and started building the software. In terms of what I think should happen in future is there should be a standardized way of every organization should be ingesting the data. That will allow this kind of analysis can be deployed across multiple institutions, and they don't have to repeat the work. So yeah, that's the reason. And we also have a plan to push the data back to EHR. But that we are still making progress on that. Right now, we pull the data from CGM devices, we pull the data from EHR, and we create a view which can be used by Dr. Tilden and his team. But in future, it will be just pushed back to EHR. And Harpreet has sent that publication details,
I
which
will
has
say that that capability that you're talking about, which I think is very important, is a capability that is had by very few institutions in the entire country. So it would be quite a cutting edge thing to do. EHR vendors do not tend to make it the simplest thing in the world to do. as they like to maintain control over the chain in general. So, Harpreet, can you also add on to that?
I agree. The good sign is that we are seeing a lot of big vendors. Like I believe it's Dexcom has a now Epic, whatever they call in applications or integrated
It
application. Now
contains,
you can.
but yeah.
Yeah. So there's the commercial reason, well, which is again in it's good to see that they are now collaborating with Epic, or I think in some cases now Oracle or previously Cerner, they also have collaborations with vendors. So we are seeing a trend going in that direction. The end of the day, when we look at EHR's goal is not necessarily, collecting this bunch of data for you to sort of start in some pop health environment. Yes, that's available, but again, that's population based, not necessarily tailored to a single person. In pop health environment, it works well. There's the whole community health environment. It can collect bunch of data, show you aggregated stuff. It does decent job of that. But when it comes to targeted, tailored approach, I think there could be that, it's just when it looks at revenue, why it's not like the very high revenue area where eventually they'll start focusing on. But right now, the need, it's so different for every community that just recording CGM data in EHR is a step in right direction, but not enough. So it also depends on, sometimes as Love pointed out earlier, C XCOM might be too expensive and LibreView is not supported very well in EHR. So just taking all that into consideration, Datadog takes away that dependency. It can ingest from pretty much any big vendor right now we have in US. And then it has a stream outward. You can take that stream and put it in EHR as an observation per person. That's an interest to your organization. So again, thinking out loud is like you're taking you're basically separating those two big components and tailoring it to as you need. But if you ask me, like, if I had magic ball in 5 to 10 years, I think you'll probably see EHRs getting a lot more interested because how we are seeing rise in type 1 and type 2 diabetes patients, and CGMs are becoming a lot more affordable. Now you can have a Dexcom for, I believe, 2 weeks. I might be wrong, but you don't have to keep poking yourself again and again. So there's a good trend happening that you can see that in the next few years there will be a spot in the bigger players.
I'm going to reparse what I hear you both saying, and you can disagree with me if you will. So, what I'm hearing you say is that innovation in the AI space with respect to wearable data and in many areas requires flexibility because if we wait for a vendor to do something, it may not have the financial return for them to be prioritizing what they're doing. But maintaining a platform that has capability in a very standardized and general way to connect to whatever we need it to gives us the ability to flex as needed when innovation is possible. Would you agree with that statement? And
I believe so.
one of the examples I have of this and why it can be critical at times actually goes back to the pandemic. So we at KU would maintain a tool called C3OD, or the Created Cancer Clinical
Mhm.
Outcomes Database. And many times I've been asked over the years why we maintain this tool when we have something like Slice or Dice or built into Epic as well. And what happened during the pandemic is we had this critical need with our cancer patients to be able to identify people who had been diagnosed with COVID so that we could run studies and better understand that population in a very short frame of time. The codes to do this were not available in Slicer Dicer at the time. Within C3OD, we were able to add those in a system that we controlled within just a couple of days to be able to create that phenotype to be able to identify those patients. And then those studies were able to run the week after that request came through. And that's where innovation lies in my mind, is you have to have that flexibility to innovate. You have to have the innovative ideas, but if you don't have the flexible platform that allows you to do it, it'll take you a couple of years to even get started.
It's kind of, you can think of as infrastructure is ready to use. It's just you may able to do it way cheaper if instead of like starting from scratch, it's already there. You don't have to pay for the entire. If you have started from scratch, you will pay way more money. Um, the data is there. You just have to define your study, and you can share the cost across multiple PI.
I will say another thing that I ran into in the past was I, at one point, was part of a group that developed, I will not name the vendor, a proof of concept model that was able to identify based on an implantable heart monitor people who would be readmitted within the next 7 days. And it was able to do so with a very high level of accuracy, but the vendor controlled the data and was not interested in pursuing the idea, and the project stopped. And so being able to connect accessible data to your AI is a key aspect of everything that we're talking about. So bringing it back to wearables, what's the next impactful step for us that would really, I think, help to open up more innovation in this space? What is it that we need to do next?
I think it's again, I this is just my perspective on it because I think we're just scratching the surface right now, to be honest with you. It's so one example I'll give you, we went back to Garmin and said, your step count looks great, but by the way, that's exactly how do you count a step? And they were like, no, there's the math is, there's a lot of averages involved, a lot of expectations. So just, I think the next big thing is understanding exactly what these devices are putting out and just understanding these minute differences between, hey, is a clinical grade device versus a publicly available, widely used device, are they in similar ballpark? If they are, it can expand the use of these devices. Right now, we are limited a little bit because in some wearable device, and I'm also including clinical grade wearable devices like your detectors, your accelerometers, they are the clinical grades are also for wearable devices. We collect that data as well. So GPS data. So that's where researchers are thinking in the wearable space. I'm talking generally about. I think the algorithms are getting better. Bigger companies are investing more money. So just understanding for a research perspective, understanding what you're getting is important. So I think teams should invest in that knowledge base for the new researcher to come in. That's one thing. In just in the way I look at it, that informed consent of like, okay, this is where I really go. And you can say, okay, well, this looks great. Let's build this particular model on top of this XYZ component. And that's where having like predefined services will be helpful. Again, my opinion is you'll see a lot more targeted approach towards like health conditions and like CGM. Now for sleep apnea, there's actually a device which can sting you. Uh, it basically gives you electric shock, and again, I'm not a physician. What muscle it is, I don't know, but that device has now an API, so you can tell how often you got stung at night. So again, you'll start seeing the air quality is one of our big things. So we have a big collaboration with CDC, a project we did for North, I believe it's KCPS, not just North Kansas City. So just trying to detect what's going on in the air and being able to detect that in near real time that this virus is really exploding and suggesting the KCPS administration, hey, by the way, you might want to take a day off next week because this strain of virus is not looking that great and your kids are not coming to school. I think that's where variable the definition is going to expand, accuracy is going to expand, and just the scope, what type of research we can do is going to expand. So I think it's just like having Microsoft Excel. Now every institution has Excel. You'll probably start thinking about variable as being that core component for research institutions across the country.
Awesome.
Again, my take on it.
What do you think? What do we need to do next?
I think the biggest impact we can have is if we can have machine learning model built on DID data set, and then if we can deploy it on a wearable device like Garmin or Apple, which creates like clinical level information for patient. That's the big impact we can have. And the path is not straightforward, but instead of patient coming to physician, it's they get informed directly. And those machine learning models are like clinical grade, what we use at here. Um, that's the big impact we can have, like probably next 3 to 4 years. And as smartphones and as wearable device gets powerful, we can actually deploy those things at the device rather than pulling the data and doing the analysis at the local level, at the university or hospital level. So that's something I think like that will have a big impact if someone can do that. Um,
I'm going
and
to suggest one other possibility there to build on top of that, which is, okay, everybody has heard about vibe coding. There are things that are great about it, and then there's all the work that we have to do after somebody's vibe coded something because the code is terrible and now it actually needs to be fixed before we can deploy it. And actually, usually we throw it away and just build what the person's built from scratch. But it does serve a purpose in terms of if it can very quickly prototype something and show you that the concept is valid. But I think there's a step that's in between the sort of we start and do a full development stack for something and vibe coding, which is if we can provide people with blueprints for how to accomplish common types of AI workflows, right, and make that accessible to people to get them started, we'll probably greatly accelerate the work that people do in this space. Right now, okay, we can provide them with wearable data, but what do you do with it? And we can provide them with access to AI tools, but they might have some knowledge of that. But again, how do you work with wearable data in the context of an AI tool? There's a knowledge gap in between those two things. And I think we need to close that knowledge gap to really accelerate in this space. Any thoughts about how we can do that?
I think from my perspective, when we look at it, I think going back to the core idea of Jeff again, engineering doesn't change. The idea is for me to really know what's possible, that some sort of knowledge, it's some sort of information about what is a reasonable use of AI in certain areas is definitely needed. So expanding these products we are working on from just being a platform to a more of it can do this component in it. This is the particular use of this certain AI model in the case. In certain, I mean, you might have heard about agentic AI. What it's saying is you're training generic AI models to do something. Like we can take a stab at it. I don't know if you guys can you guys hear me? Okay, it looks like
Yep, we can
internet
hear
is up
you.
and down. So again, from my perspective, as an engineer, and then I've turned on the engineer hat for myself, is it's great a new initiative is there, but can I achieve it realistically? So for that, at least the expansion of these platforms is important. One give you one really good example. We try to seek some funding for a project to convert a wearable device into OMOP data set. When Love talked about generic data sets, how would you build that model? You need a well-defined ontology to put this data to really build. That's important. Initiatives in that areas and to really offer something to the not general public, but like general research population. You need something more standardized. Right now, I think Love would agree. Fitbit data looks totally different. Garmin looks totally different. Both use different algorithms. Can you build a model which works on both? In theory, yes. But will I be very confident in making that decision based on that, because I know the underlying algorithm is different? Maybe not. And that's where I think standardization would be an important component from engineering perspective.
Yeah, I totally agree what Harpreet said. Like having a standardization across multiple devices that makes life easier for engineer as well as the analyst and as well as the data scientist. It's win-win-win across everywhere. Um, and having that and giving that standard back to OMAP itself, we are giving back to the community that, oh, this is the standard everyone should use. And that standard can evolve with the time, but that can be a big win. If we have a standard way of storing the data and creating the machine learning algorithm on that data, that could be a huge win. Yeah.
Actually, first of all, I think those are great ideas. I really appreciate that response. But I'm going to bring us back to something Harpreet said earlier because there's another important piece in there, which is what is the definition of a step in terms of something like the Garmin device? And it's a trade secret, so they're not going to tell us that. And Fitbit, okay, we're in the same boat. And probably what a step means on one is not what a step means on the other. And so perhaps one of the other things that we need to do is I mean, an ontology is not going to solve that issue for us. Probably, I mean, a common approach in other areas would be I'll borrow from the imaging world where a lot of AI is done. We have two different CT scanners, and somebody builds an algorithm that uses the CTs from one machine to predict what the CT would look like from the other machine. Potentially, we could take steps from Fitbit data and use them to predict the Garmin steps, and then we actually have an algorithm for converting from one to the other. Maybe what we need to do is actually start to build that tool set for people so that they can work with these data more efficiently as well. All right, we're gonna start to wrap this up. We haven't gotten any questions in the chat, but I'm gonna pause for a second in case anybody wants to just ask a question out loud. And perhaps not, which is fine. Oh, all right, we do have a question in the chat. So can AI accurately predict the future simply by learning what normal looks like on its own? Since AI is uniquely suited to detect hidden patterns and anomalies, how effectively can it predict future health events by automatically learning on individuals' unique baseline without relying on predefined human standards? Harpreet actually did mention something related to this earlier. So yeah, what do you think about that?
I I can again, this is just the way the raw thinking comes in. I think it's put forward. Yes, in like for example, let's take a copy of model right now and you don't teach it anything. It probably won't be able to tell you much about the event that are happening in future, right? Let's say 1 year down the road and something happened after you stopped that learning, that model stopped learning, it won't be a good model to really tell you. So this idea of AI has behind the scenes, which is not very well exposed, is you have to constantly keep working on it. But when I say working, it has to keep exploring, learning. One big bias, it's pretty same as compared to any US healthcare data will look very different from let's take any other country from different continent and their healthcare. So model you build on certain data set, it's going to be different. So understanding that is important. Generic AI use is different, specific AI use is different. Now going back, how suited it is in hidden, it can. I mean, there's already some work done in I believe it has to do something with understanding how genes are built in our, we do a lot of genomic work on our end. Like it's very hard for us to see how some structures work in 3D space. So AI models can predict. It can say, looks like based on the data you're giving me for the surface, looks like internal might look like this. It also won like great academic achievements. I think Google was the one who published it. Yes, it's effective, but again, it's not. You still have to use that human in the loop component to say, okay, we are going in the right direction. Let's keep going, or no direction. And again, that's my opinion in that area.
What about you, Lav?
Yeah, I mean, all machine learning models, I'm just talking about machine learning, they need to have what is normal looks like. Otherwise, you can have like this is one group and this is another group, or multiple groups, segments. But you need to have a way of defining what normal looks like. And in the world of AI can say, oh, this looks normal. But still, you always need to have the definition of normal look like in the data itself. And then the algorithm learns from it, oh, this is normal and this is outliers. And the AI can help you do it faster. And given the AI has been trained on so many things, but when we people conflict machine learning and AI, I'm strictly speaking from machine learning perspective, you need to have really good data to define what normal looks like.
I'll add on to, so I will say to be fair, we're asking Lav and Harpreet to stretch a little bit out of their wheelhouse here. And although that answer is a classical answer that Lav just gave, there is actually a class of algorithms called anomaly detection algorithms.
Mhm.
And essentially, what those do is they learn what normal is just by looking at the data. So they're going to assume that what it sees most of the time is normal. And when it sees something that deviates from what it sees most of the time, it's going to say that is abnormal. And I'm very much simplifying in this description, but hopefully that gets the idea across. So you can imagine if you're seeing some sort of temporal trend and then you suddenly see a spike in that trend, the algorithm might be able to say, wait a minute, that is an unusual thing to have seen and set an alert. Now, I've actually experimented with this in the past, and we actually were able to use anomaly detection itself as a predictor of health outcomes down the road, even though there was no specific reason to think that the anomalies themselves were like we didn't have a biological theory as to why the anomalies were connected to the health outcomes. My point is merely that it is, in fact, possible to do this. You don't know what you're going to get until you try. But yes, in theory, I think it's a great idea for the types of things that could be done with these data. Because right now, A lot of us think that wearable data is an exciting area to be in, and we can think of some ways to use it. But this type of idea tells you, like, well, what about the things we didn't think of? And we might be able to connect some dots we didn't even know were there. I see that Dan has appeared, so I'm guessing he has a question to ask.
Maybe I might uh, do a little commentary of my own if that's allowable as well. So, um, one piece that I would add specifically with clinical applications to the question that was just asked is in the diabetes space, there is sort of increasing development and interest in the use of what they're calling digital twins, which in sort of ingest CGM data in particular with insulin data that allows the the AI algorithm to predict responses to insulin, and then they're using that to predict adjustments to insulin algorithms that will lead to optimal outcomes for blood sugars. So you're seeing both the algorithm has both the input, the insulin doses that are given, and the outputs, the blood sugar responses from the patients, and are able to adjust and tune those algorithms totally in silico. And then those are sort of approved in limited studies, are then approved by clinicians, those adjustments, and then they're able to see what those responses actually look like in real life. So just some cutting edge work that I think responds somewhat to that question.
Now, I will
The
say
other
that, oh,
Go
sorry, go
ahead.
ahead.
No, no, no. I have a separate comment on an earlier topic, which is just this discussion about standardizing data, and I think the importance of that in this space. This is an area where I think interested parties like the folks on this call within their specific domains have a real strong opportunity to try to work with and build coalitions, both among clinicians and then also including um, industry. So what we've done in our work through the Rising Tide Alliance in collaboration with folks at Lurie Children's is to build a set of standards both for CGM data called the I-code standards. So there are I-code 1 and I-code 2. And there's an upcoming release of I-code 3 that will include not only continuous glucose monitor, blood sugar, standardizing sort of what that output looks like in formats, but also are going to begin to include insulin data, where in our sort of diabetes focused world, where there's a lot of similar barriers in how folks are measuring and displaying outputs, being different, sort of significantly different across manufacturers, and that having implications for our ability to have a standardized data set from which we can work from.
Yeah, that's
The
great.
other,
I mean, going
yeah,
back to the source and
yeah.
making sure that data are comparable there is even better when it can be done. Yes.
And we're doing that both in collaboration with clinician groups, but also with patients. And so we're right now working to develop a set of standards for integration between the EHR and CGMs, so that with a key focus of that work to prioritize patient data availability. So, there are anti-information blocking provisions specifically focused on electronic health records, but those don't necessarily apply to continuous glucose monitor data and other wearable data. And so, because the device manufacturers aren't necessarily regulated by the same set of standards that the electronic health record vendors are. And so there are important conversations happening in a number of different avenues. And I just would encourage this group to seek out within your specific domain areas where those conversations are happening, and just advocating for the free flow of data. I think that benefits both patients and clinicians and researchers interested in this space.
Great thoughts. Thanks, Dan. I'm going to connect us back really briefly with the last few minutes we have here to digital twins. I want to give people a little context there because it's an interesting example. Although the definition of digital twins has been stretched somewhat in recent years, including by myself, so I can't complain. Classically, the idea of digital twin, which does not originate from healthcare, is to without, you can pretend you don't hear me when I talk about this part, but it is to use differential equations to create a mechanistic model of the thing that you're trying to twin. And that is still the most commonly used method. Can I create a mathematical model that gives me what is called the counterfactual? If we were to have given somebody a different medication than we gave them, what would have happened to them in that circumstance? We can fully describe the system at hand. We have a digital twin, and then we can predict what would happen under various choices that we might make. So that said, a recent innovation that happening in this space that is applicable to the topic at hand with wearables is that those differential equations can now actually be estimated themselves using machine learning methods. So although I would say differential equations have always been AI, as in we use a computer in many cases to do something a human would normally have done, they didn't involve machine learning. They involved math. So now those sometimes very difficult to create differential equations can be estimated in some cases using neural networks. And then we can connect them back to an interpretable model using some other methods that I won't even talk about. And so innovation's happening at that algorithmic level that allows us to go into this digital twin space in a way that we've never been able to before. And that means for all of us that the idea of applying AI to wearables and even creating causal mechanistic models is now a much more approachable topic. So I just put that thought out there because maybe you haven't thought about the fact before that that is a thing that is potentially doable. All right. There's only a few minutes left. I'm going to pause again just in case there's any final questions or thoughts. And if not, I'd really like to thank our panelists, Harpreet and Love, for the time today, and thanks to everybody who came to listen. I think we had a great conversation.
Thank you.
Thank you.